I started as an experimental psychologist, and I was not interested in robots per se. I was interested in the brain. Over the years, though, I came to the realization that in order to better grasp and better understand how biological intelligence works, is to synthesize that intelligence in computer programs and look how it behaves. And we believe that that will give us intuition on actually how the brain works. So NASA came to us with a very tough problem. NASA wants to create robots that are increasingly autonomous, that can be sent to space, they don't require a lot of sensors, but they can still perform efficient navigation, for instance, without requiring GPS.
So rather than telling the Mars rover where to go exactly all the time, NASA and their affiliates are trying to get the rover to kind of increasingly drive itself so that they can give high-level instructions. This is especially useful for kind of driving into caves where you can't always send instructions to the rover. So you want it to explore these lava tubes or caves where you can't communicate with it, and you want it to come back up afterwards.
So it turns out that biological intelligence is really good at performing all this operation without the need of fancy sensors or GPS signals. And what we did is we successfully demonstrated that a robot can navigate and orient itself, recognize things in the environment without needing a lot of expensive sensors.
So the way a camera sees is very different than what we see. It's just it's a set of numbers, just like this grid of numbers. And somehow you have to turn that grid of numbers into something intelligent.
We have developed an object recognition system called CogEye, and basically what it does is if you give it an image, it'll look at the important objects in the image, it'll look at different views of those objects, and it'll learn to recognize them so that if given new views, it can classify them properly.
In a sense, you feel like you're trying to recreate life, or at least a very narrow slice of life, which is biological intelligence. And it's a gargantuan effort even to simulate something really small, say a small network of neurons in the visual system, and it makes you really appreciate the complexity of biological intelligence.